Hey there, AP Environmental Science class. Welcome to part one of my lecture on Chapter 16, Environmental Hazards and Human Health. We're dealing with about 60 slides for this chapter. So once again, I will break it up into two parts, part one and part two. So again, this will be a part one starting now. So once again, Chapter 16, Environmental Hazards and Human Health. All right, so here we go. So we start off with a core case study talking about mercury. Mercury is a very toxic compound. All mercury compounds are toxic. In fact, we used to use them in the thermometers way back in the day. Now those school thermometers that we get, or any thermometer that you get, if you see a red liquid inside, it is no longer mercury because mercury was used previously. But again, it is toxic. Again, all mercury compounds are toxic. 1/3 in the atmosphere of mercury in the atmosphere comes from natural sources. 2/3 of mercury in the atmosphere come from human activity. So obviously we're putting more mercury into the atmosphere than is there naturally. Two main types of human exposures to mercury. One is fish contaminated with mercury. You may have heard about this. And the second type is inhalation of vaporized mercury. Mercury can cause birth defects and brain damage. So obviously it is a toxic compound. And maybe you've noticed this, fish contaminated with mercury in many lakes. This one is in Wisconsin. You probably heard about this. For instance, sushi, right? I love sushi, but I don't eat sushi that much. I would eat it every day of the week if I could, but the problem is a lot of the fish have mercury in it, and mercury gets basically mercury gets biomagnified as it goes through the food chain. So we spoke about that biomagnification in previous chapters. A little fish has some mercury in it. Bigger fish eats that little fish. The mercury content increases. Then a bird comes in, eats that fish. Its mercury content is higher. And then maybe we kill that bird and eat it or something like that. And then obviously we're ingesting that mercury that again gets biomagnified as it goes up the food chain. So you'll hear about this a lot, especially with fish being contaminated with mercury. And that's why, again, you don't want to eat sushi every day because unfortunately that could increase the mercury amount of mercury that you have in your body. All right, so what major health hazards do we face? Well, the major types of health hazards that threaten human health can be broken down into these 5 categories: biological hazards, chemical hazards, natural hazards, cultural hazards, and lifestyle choices. And what we'll do is we'll go through and kind of talk about each one of these in a bit more detail over the next couple of slides. All right, so we face many types of hazards out there. A couple of terms that you'll need to know. What is a risk? Well, a risk is a probability of suffering harm from a hazard, usually expressed as a ratio or a percentage, right? So I got a 50% risk, a 50% risk of something. I got 50% chance that I'm going to be harmed by that hazard, right? If there's a 30% risk, there's a 30% chance that I will be harmed by that hazard, et cetera, et cetera. Risk assessment uses statistical methods to estimate harm. This would be to kind of predict in the future the type of harm that could come from some type of hazard. And again, using a statistical method, that is risk assessment. And then what is risk management? Well, that's deciding whether and how to reduce a particular risk, basically managing that risk, right? How are you going to manage it? And there are jobs out there in this field, especially in the insurance field. So something that you may think about as you go off into the college world and into whatever career you're going to do. Insurance industries do this risk assessment, this risk management a lot. All right, so what do we do in a risk assessment? We basically identify the hazard. What is it? We basically then calculate its probability. How likely are we going to have to deal with that risk or that event? And then the management, right? The consequence of that risk. What is the likely damage and how are we going to mitigate that damage? So that's what our risk assessment does. Risk management then does a comparative risk analysis. How does it compare with other risks? Again, when you're trying to manage a risk, you may want to compare it to others to see see how you may want to handle it. Risk reduction, how much should it be reduced? We need a risk reduction strategy. How are we actually going to reduce that risk? Again, the management part of it. And then a financial commitment, because unfortunately, with most risks, when it comes to environmental especially, you're going to need to spend some money in many issues to mitigate the risk. So again, this is all part of that risk management. All right, so what are biological hazards? Well, they're basically pathogens, right? Organisms that cause disease in other organisms. That's a biological hazard. A chemical hazard are harmful chemicals in the air, water, soil, or food that we may ingest or breathe or drink. Natural hazards are going to be created by nature: fire, earthquakes, volcanic eruptions, floods, tornadoes, hurricanes, etc. Cultural hazards are going to be unsafe working conditions, criminal assault, and poverty. Again, hazards that come because of the culture that you may be living in, depending on where you may be living. And then obviously lifestyle choices. So cultural hazards, you kind of, all the ones we talked about up to lifestyle, you really don't have much of a choice, right? It's kind of going to happen to you if it's going to happen to you. The lifestyle choices, though, these are the choices that you and I make individually that could cause hazard, like smoking or making poor food choices, or maybe having unsafe, unprotected sex, right? These are lifestyle choices that you and I decide to do, but obviously some of those choices can bring some hazards into play. So something to think about. All right, so let's first talk about biological hazards. How do biological hazards threaten human health? Well, the most serious biological hazards we face are infectious diseases. Examples: the flu, acquired immune deficiency syndrome, AIDS, tuberculosis, diarrheal diseases, and malaria. Okay. And you may be able to throw COVID into here as well, right? That's kind of the new one that we've been dealing with now. So COVID can be thrown in here as well. These infectious diseases. So infectious diseases, pathogens invade the body and multiply. These pathogens could be viruses like COVID, like the flu, could be a bacteria, or could be a parasite. So those are basically the ways that we get these infectious diseases. A transmissible disease is contagious or a communicable disease. So again, COVID, you can think about that. Infectious diseases are transmitted between people. Examples: the common cold, tuberculosis, gonorrhea, and again, COVID you can throw in there as well. Non-transmissible diseases are not caused by living organisms. So examples would be cardiovascular disease, cancers, asthma, and diabetes, right? You can't, if you have cancer, you can't transmit that cancer to somebody else. If you have heart disease, high cholesterol, things like that, you cannot transmit that to somebody else. So these are called non-transmissible diseases. They're not caused by a living organism, a virus, a bacteria, and again, you can't transmit them. What is an epidemic? A couple of years ago, students may not have known these terms. Now I think you guys are pretty aware of these terms, right? An epidemic is a large-scale outbreak of an infectious disease. What is a pandemic? Well, basically an epidemic on a global scale, like we've been dealing with COVID again. So you guys, unfortunately or fortunately, are kind of becoming experts on these epidemics and these pandemics over the past couple of years. So the WHO, the World Health Organization, estimates that the world's 7 deadliest infectious diseases, again, not including COVID here, kill 8.3 million people per year. Most of them are in underdeveloped and poorer countries, right? So you'll notice these are the 7 main deadliest diseases here: infectious diseases, so lower respiratory infections from bacteria, viruses, okay? And I guess you can maybe put COVID into that, but obviously the deaths would be higher here if COVID was factored in. Tuberculosis, number 2, which is a bacteria. There you have HIV and AIDS, which is a virus, at number 3. Hepatitis B, a virus, number 4. Diarrheal diseases like bacteria and viruses that can dehydrate people. They're number 5. Malaria, which is a protozoa, number 6. And measles, which is a virus, number 7 there. So again, these are the 7 deadliest diseases. World Health Organization, about 8.3 million people per year die of this. And again, COVID is not on this list, but these are diseases that have been around. And again, maybe you could throw COVID in that lower respiratory infections category, which is up there on the top. All right. Infectious disease was the leading cause of death in the world in 1900. The incidence of infectious diseases has dropped significantly since then. However, it is still a problem, especially in less developed countries. Many disease-carrying bacteria have developed genetic immunity to widely used antibiotics. Again, we spoke about that. Think about when we went back to that pest control a couple of chapters ago, right? How you have a pest on corn, you spray the pest with a pesticide. Everyone but maybe one or two of them live because they have a mutation that allows the animal to be resistant to that pesticide. And then over the course of a couple of generations, you now have a group of pests that are immune to the pesticide. Well, same thing happens with a disease-carrying bacteria with antibiotics, right? You put antibiotics, kills most of the bacteria, but there might have been a mutation in one or two, so they survive. And then as you go through the generations, and again, bacteria multiply very quickly, so they have really fast generations, right? You end up getting a bacteria strain that is resistant to the antibiotic. So that is why, again, to each his own. But when I get sick, I usually don't go get an antibiotic unless I really, really need to, because I don't want my body or these diseases to be to get immune to the antibiotics, right? So I only use them if I really, really have to. I let my natural body defenses kind of handle it, just like we talked about in pest management, right? Let the nature handle the pests, or not necessarily use pesticides. I kind of feel the same way with colds. I kind of let nature, myself, handle the cold before I go get an antibiotic, only as a last resort. Climate change will allow disease vectors, or basically what are vectors? Those are the organisms that cause disease, like bacteria, like viruses, etc., to increase their range, because again, climate change allows that. Okay, so because of climate change, there is the chance that we are going to have more infectious disease, not less, as we go through time. All right, so case study here: the global threat from tuberculosis. All right, tuberculosis was high on that list. What is tuberculosis, or TB? It is a highly contagious bacteria infection of the lungs, and it's been spreading again since 1990. Why is it on the rise? Well, we have a lack of screening and control programs for tuberculosis. Genetic resistance to a majority of the effective antibiotics. Again, TB has been around for a long time. We've tried to mitigate it, but now you have strands of TB that are resistant to those antibiotics for reasons I just told you about. Person-to-person contact has increased, right, as we begin to move into more urban areas, things like that. Obviously, population growth, air travel, and urbanization has obviously brought tuberculosis maybe to other areas that maybe it wouldn't have been there previously. So these are the reasons why it is on the rise, and you'll notice what it does to the lungs here. Red areas are where the tuberculosis bacteria has destroyed lung tissue. So you can see, obviously, if it destroys your lung tissue, you won't be able to breathe. You won't be able to get the oxygen into the blood, and then unfortunately, your body will shut down and you will die. So obviously, major impacts from tuberculosis. All right, so let's talk about some of the world agencies that kind of work with infectious diseases. First, we have the United Nations, which promotes dialogue between countries with the goal of world peace, and also world everyone healthy as well, right? They deal with world matters and international health matters as well. We have the WHO, the World Health Organization, improvement of human health by monitoring and assessing health trends throughout the world. And then we have the World Bank, if needed, which provides technical and financial assistance to developing countries. If there is an outbreak of tuberculosis or a disease, or like we're dealing, or like COVID, right? The World Bank may step in and supply countries with money they need to help mitigate the risk from these infectious diseases. All right, so just understand what these world agencies do. All right. So, talking a little bit more about viral diseases and parasites. Again, they are killers. Influenza or the flu virus kills the most worldwide. Again, we can throw COVID in there as well. The human immune deficiency virus, otherwise known as HIV, which again produces AIDS, infects about 2 million people yearly. We have the hepatitis B virus, HPV or HBV, excuse me, Ebola, West Nile virus, and the Zika virus, which we sometimes get in this area with mosquitoes. You've definitely heard of West Nile and Zika. Zika was a couple of years ago. We haven't had much of that recently, but every spring, fall, summer, we do get patches of West Nile virus here in the tri-state area. Here in Ardsley, they show up in mosquito pools, and so it's just something to be aware of. Viruses that move from animals to humans, all right, basically, that's what COVID is, a new field of ecological medicine here. Good hygiene can reduce the chances of infection. Again, a couple of years ago, maybe this wouldn't be common knowledge, but what we've been going through over the past couple of years, we all know this now, right? Wash your hands. Do not share razors or towels. Cover cuts and scrapes until healed. Avoid contact with people with viral diseases, and do not touch your eyes, nose, or mouth if possible. Okay, so all things that we can help our risk, right? Lower our risk. Basically, this is risk management, right? Managing the risk so that it can be lower. All right, core case study. Need to talk about the global HIV and AIDS epidemic. Yeah, you don't hear much about this anymore. When I was growing up, when I was your age in the 80s and 90s, this was a big thing. Still, though, affects people worldwide. So the only reason it has left the front page is because, unfortunately, in news, people just get tired of writing about the same thing over and over again, and so it basically gets lost, even though it's still a big issue around the world. Maybe not so much here in the United States, but AIDS, caused by that HIV virus, leaves the body vulnerable to infections. It basically compromises your immune system. So AIDS and HIV doesn't kill you, but what happens is you get this disease, your immune system is compromised, and then something like a basic cold could kill you, right? Would kill you because your immune system isn't working as well. Leading cause of death for people ages 15 to 49 worldwide. Think about that. Now, again, not so much in this country, mainly in underdeveloped and poorer countries. But right now, it is still a problem out there, the AIDS, HIV epidemic. No vaccine to prevent or cure AIDS. We haven't been able to figure out this one. There are some costly drugs out there that can slow the viral progress. But again, they're very costly at this stage. They have been coming down a bit. All right, so what are we looking at here? This is a population pyramid here in Botswana, where 25% of ages 15 to 49 are infected with HIV. So what this is projecting is how Botswana is going to look age-wise with AIDS and without AIDS. And you'll notice what's going on here, right? With the AIDS, you're having not a lot of people reach maturity, and you're having a lot of less people here down, a lot of less kids being born, because unfortunately you're losing a lot of people in that age-bearing range, right? Because those people ages 15 to 49 are dying. Without the AIDS, you'll notice how it is more of a stable pyramid here, right? It's kind of looking unstable with the AIDS, and that's because you're losing a lot of those people in the childbearing ages. So you're not, A, you don't have a lot of older people, and B, you don't have a younger people. So obviously what we remember from the population chapter, unfortunately, when you have a pyramid that is unstable like that, the population could collapse in that country. And again, that's what we worry about when we look at AIDS or any other of these epidemics out there that could potentially destroy countries, because you're destroying the population. Next case study we talk about is malaria. The malaria is actually a deadly parasite that is injected into people's bloodstreams from mosquitoes. Malaria is caused by parasites that are carried by certain mosquitoes, mainly in tropical and subtropical regions. They spread. Uninfected mosquito bites an infected person, later bites an uninfected person. So that's what happens. Mosquito bites you. You were infected at some point. The mosquito then sucks your blood into it, right? Because that's how mosquitoes, they suck your blood. That's what they want to do, because that's their food source. Then they go to another human, inject their stinger, their sucker into your body, and they're basically giving you a little bit of that blood that has the parasite in it from another human being, and now you are infected, and this is how this spreads. Climate change expected to spread malaria to warming temperature areas. That's what we talked about when we said those disease vectors would change with climate change, right? Mosquitoes like those warm, wet, kind of humid conditions. So with global warming and climate change, areas that aren't necessarily tropical or subtropical may become tropical and subtropical. And so now you're going to introduce these excess mosquitoes, which could be carrying this parasite that produces malaria. And this, unfortunately, could spread malaria to places where it has never been before. Again, that's climate change. Malaria incidence has actually been increasing since 1970. We kind of got rid of most of it in the early 1900s. But the problem is now, again, we have drug-resistant Plasmodium parasites. Again, a different parasite, or at least an evolution that allowed the parasites to become resistant now to the malaria drugs. And so now you're seeing an increase in malaria again. Again, insecticide-resistant mosquitoes as well. Same thing we talked about, right? Pest control. But the problem is, you use these chemicals, and the mosquitoes, because they, there are selective species, right? They reproduce so very rapidly that you basically get them to be immune to any of your insecticides over a course of a few generations because of those genetic mutations. So again, because of this, we're seeing malaria increase again. No effective vaccine for malaria. Insecticide-treated bed nets and window screens have saved over 6 million lives between 2000 and 2014. And in fact, this is a picture of what I'm talking about here. This is in Senegal in Africa. And this young child here is sleeping under an insecticide-treated mosquito net. In a hope that he will sleep peacefully and not have any mosquitoes carrying malaria bite him and transmit malaria or her to this baby here sleeping under these nets. So these nets have helped, but again, they're not going to be foolproof when it comes to malaria. All right, so how can we reduce the incidence of infectious diseases? Well, the percentage of worldwide deaths from infected diseases has dropped from 35% in 1970 to 16% in 2015. Why? Because more children are being immunized around the world. And I would also argue that we know more about, health now. We know more about, how fresh water is important, how cleaning, washing your hands, doing things like that. So again, just simple stuff has helped. And again, having more children being immunized to these infectious diseases also helps as well. For instance, measles, mumps, things like that. And average annual deaths from infectious diseases in children under age 5 reduced from 12 million to 4.9 million between 1990 and 2015. So another success story. And again, the reason is kind of things we talked about previously. So here are some solutions to continue to reduce the effects of these infectious diseases around the world. We need to increase research on tropical diseases and vaccines, reduce poverty and malnutrition, right? If you have money and you have more food, there's no food scarcity or food insecurity. If you're nourished properly, then your immune system will work at its ultimate peak, and that will hopefully keep you alive if you do encounter an infectious disease. Improve that drinking water quality. Again, that has definitely helped over the past 100 years. Clean water, basically you don't have these diseases in. Dirty water you do, right? And so many people have been drinking dirty water. Luckily, we've been improving that. We need to continue to improve the drinking water quality. Reduce unnecessary use of antibiotics. Again, only use them when you really need to. Sharply reduce the use of antibiotics on livestock for reasons we've spoken about. Immunize children against major viral diseases. Provide oral rehydration for diarrhea victims. Okay, what's the big thing with diarrhea? It dehydrates you. So give people oral rehydration. And again, conduct a global campaign to reduce HIV and AIDS. And honestly, you want to conduct a global campaign to reduce all of those infectious diseases. All right. How do chemical hazards threaten human health? All right, and this will be the last. We'll talk of this for a couple of slides, and then that'll be it for today. So again, we spoke about the infectious diseases. Now we're going to dive into the chemical hazards a bit more. So certain chemicals in the environment can cause cancers and birth defects, can also disrupt the human immune, nervous, and endocrine system. So toxic chemicals, all right, some chemicals, carcinogens. Carcinogens are chemicals, types of radiation, or certain viruses that can cause or promote cancer. All right, they are called carcinogens. Mutagens are chemicals or radiation that can cause mutations or increase the frequency of mutations in cells. And then we have teratogens, which are chemicals that cause harm or birth defects to a fetus or an embryo. All right, so please understand these three terms: carcinogens, mutagens, and teratogens, and what they basically mean. Carcinogens produce cancer, mutagens produce mutations, teratogens produce birth defects in a fetus or an embryo. All right, so going to look at PCBs, a legacy from the past. This is a case study. This is a class of chlorine-containing compounds, which are very stable, non-flammable, break down slowly in the environment, travel long distances in the air. They're fat-soluble, and they're biologically magnified in food chains and food webs. Luckily, PCBs are now banned, but they are still found everywhere. PCBs, again, this is the biomagnification of them. You'll notice water, how small it is. By the time you get to herring, gull, eggs, you have 124 parts per million of those PCBs. So again, this is a type of chemical hazard. We have banned these since the Montreal Protocol in the late 1980s. This PCBs were producing the ozone hole as well. And we'll talk about ozone in a couple of chapters. But now they're again banned, but they're still out there. And again, because of the biomagnification, they can still lead to some problems. So understand that core case study. All right, this will end part 1 of my lecture on chapter 16, environmental hazards and human health. Again, make sure to check back in for part 2. And as always, thanks for listening.